Hello students, welcome to the second part of the 42 volt system. Myself Shankhu Ghosh, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Su Degree Engineering College under the JIS group. Today we will discuss on the second part of the 42 volt system, which is taken from the module number 7 from the subject of modern vehicle technology. The subject code is AUE 704B and this is the 7th semester automobile students subjects. So students, in the previous class we covered the basic of the 42 volt system and the difference in between the 42 volt system and the conventional 14 volt system. Then we discussed the challenges those faces the researchers and the automakers on this 42 volt system, and after that we discuss the various measuring component. Now today we will continue this class. This is the 42 volt system as part. So student, let's start the today's class. In the last class we discussed the new manufacturing and test requirement, which has the two types. Number one is simplifying and speeding up the measurement, and second one is Ethernet based test solution. Previous class we discussed the simplifying and speeding up measurement. Now today we continue this class on the topics of Ethernet based test solution. So student, let's start with this Ethernet based test solution. Ethernet based test solution. The switch to 42 volt system will be on a fast track. So test data sharing across the enterprise will be important. So test data sharing across the enterprise will be important. Today that often means feeding the data to multiple departments across the Ethernet bus. Ethernet bus, having the Ethernet ready instruments with tightly integrated measurement and switching functions, and the switching function greatly simplifies this task. Switching function greatly simplifying this task. And additional benefits of Ethernet based measurement solution is that the test engineers do not have to track measurement accuracy for the convenience and cost effective data collection. While PC is plug-in card provided low cost, measurement quality usually is much lower than that available with the benchtop instruments. When the benchtop instruments instrument also has an Ethernet ready interface. The test engineer get the best of the both worlds. This becomes increasingly this become increasingly important in a production environment with many test stations or the multi-point sensor. In such cases, it is often more cost effective to use an Ethernet based instrument than to install the multiple PC based plug-in card system. Now coming to the next topic is that the automobile accessory power. The automobile accessory power can be transferred. The automobile accessory power can be transferred by the several different means. However, it is always ultimately derived. It is always ultimately derived from the automobile's internal combustion engine, battery, or the other prime mover source of energy. The advent of high power batteries in hybrid and all electrical vehicle is shifting the balance of technologies even further in the direction of the electrically powered accessories. An engine has one or more devices for converting the energy which is produced into a usable form. Electricity connection. The electricity connection through the alternator, hydraulic connector, and from a pump or an engine system, compressed air, and the engine vacuum, or the engine may be directly tapped, through a mechanical connection. Engine has one or more device. The engine has one or the more device for the converting the energy it produces into usable form. That the electricity connection through the alternator, hydraulic connection from a pump or an engine system, compressed air, and the engine vacuum, or the engine may be directly tapped through a mechanical connection. The modern vehicle run most accessories on the electrical power. The modern vehicle run most accessories on the electrical power. Typically only 2% of a vehicle total power output has gone towards the powering accessories. The electrical and the hybrid vehicle must use the electrical and the hybrid vehicle may use a larger proportion of energy for exercise due to reduced the inefficiency in the drivetrain, especially the elimination of engine idling, especially the initially of the engine idling. There's two picture. One is urban driving, and second one is the highway driving. For the urban driving, this is the engine. The 100% fuel is input. After the 100% burning, 17% goes for the standby, and 62% engine loss. 19% from the engine of 19% goes to the drivetrain, and 2% go for the exercise. The 19% of the drive line is divided into two parts. One is one that is 13% go for this wheel, and number 6% and 6% is going for the drivetrain loss. And then this 13% is goes in divided into three parts. That is aerodynamics, which is 3%. Second one is rolling, that is 4%, and third one is the braking, that is 6%. So this is the urban driving mobile exercise. Second is the highway driving. After the 100% of fuel burning inside the engine, 4% goes for the standby, 69% goes for the engine loss, and 2% goes for the exercise, and the rest of the 25% go for the drivetrain. Then this 25% of drivetrain divided into two parts. One is 5% and another is 20%. 5% is the drivetrain loss, and for this 20%, it is divided into three parts. One is aerodynamics, that is 11%. Second one is rolling, that is 7%, and the third one is the braking, that is 2%. So this is the picture of the highway driving automobile exercise. So these are the pictures of the driving exercise. Next is 42 volt system. Due to the increasing the electrical loads, due to the increasing of electrical load, automotive systems are becoming more electric. Automotive systems are becoming more electric. Therefore, mechanical will need highly reliable, fault tolerance, autonomous, controlled electrical power system to deliver high quality of power from the source to the load. The voltage level and the form in which power is distributed are important. A higher voltage such as proposed 42 volt will reduce the weight and the volume of wiring harness among the several other advantages. In fact, increasing the voltage of the system, which is 14 volt in the conventional car, is necessary to cope with the greater load associated with the more electric environments in the future cars. The near future average power demand is anticipated to be 3 kW and higher. Here the picture shows the concept of the dual voltage automotive power system architecture of the future car. Indeed, it is a transitional 2 voltage system which can be introduced until all automotive components evolve to 42 volts. Finally, the future MC power system will most likely be a single voltage bus, that is 42 volt DC, with the provision for hybrid, that is maybe DC or AC, multi voltage level distribution, and intelligent energy at a load management. As we can say, there is a two battery. This is the first one is the battery one, this is the battery two. Battery one is the 36 volt battery and battery two is the 12 volt battery. 36 volt battery is connected with this 42 volt DC bus, and this DC bus is connected with the load, DC to DC converter, bi-directional power converter, alternator starter, and the IC engine. And the other way, the battery 2, that is a 12 volt battery storage system, which is connected with the 14 volt DC bus, connected with the loads and the DC to DC converter. Next is hybrid system. To ensure a smooth transition, electrical system will not be completely to ensure a smooth transition. Electrical systems will not be completely converted to 42 volts in one giant step. Instead, the auto industry will go through a period when the vehicles are equipped with the both 14 and the 42 volt architectures. Trapp says the dual 42 or the 14 volt system, dual 42 and 14 voltage system is an interim step that is expected to be the norm for the several years. Low voltage devices such as radio will continue to use the 14 volt, will continue to use only the 14 volts. The components that draw a large amount of energy, and run more efficiently at higher power, such as seat heaters, will benefit from the 42 volt system, says the Upland Boundary Vehicle System Engineer at Christian Crop, Deborah and I. And it is more economical. The dual voltage system will require two batteries. One is traditional 12 volt battery and another is a 36 volt battery. So students, for the 42 volt system, a dual volt system will require two batteries. One is 12 volt battery and another is 36 volt battery. The 36 volt battery will take current from a new generation of higher voltage alternators. The 36 volt battery will take current from a new generation of higher voltage alternator. while the 12-volt battery while the 12-volt battery charge will charge directly from the 36-volt inlet. The dual voltage systems are inevitable because suppliers are not ready with all the 42 volts component. All the 42 volts components says the components, and and it also becomes a question of how to roll everything out in a cost effective fashion. The dual volt alternative gives suppliers time to develop 42 volt components. The cost to convert to purely 42 volt would be cost prohibitive right now. A gradual changeover minimizes the cost of simultaneously changing all the vehicle system to a new standard. Also, not all components benefit significantly from increased voltage, such as certain sensor and the spark plug. In fact, radio and incandescent lighting system actually operate better at the 12 volts. The two battery system present short-term challenges such as extra wiring, extra weight, and added complexity. In addition, suppliers need time to develop a part identification system to distinguish between 14 and the 42 volt components. Different sizes, colors, and marking will probably be used. As vehicles complete the transition to a 42 volt system, the power and the signal distribution architecture will be reconfigured to a single system. At that point, wear gauge will be reduced. Wear bundle sizes will shrink. Smaller connection system will be utilized, and mass and cost will be substantially decreased. The initial and routing of the wiring system within the vehicle will be simplified, and a new vehicle design opportunities will be realized. Now coming to the outline of this hybrid system. Here is the picture of the 22 mil hybrid system. Here we can see a 42 volt battery backpack is used for the mild hybrid section. So this hybrid system or the mild hybrid system is aimed at reducing the exhaust gas emissions, fuel consumption, and the idling noise by adding new functions ideal stop, in particular to conventional internal combustion engines. The following functions are provided. The following functions are provided according to vehicle running condition. According to the vehicle running condition. When stopping the vehicle, number 2, when starting the vehicle, number 3, when running in ordinary condition, 4 is when decelerating. So let's start with this. When the stopping the vehicle, the engine stops promptly and smoothly while being controlled by the motor or generator, that is it is for engine. Upon request for the activation of the air conditioner or the power steering, the air conditioning compressor or the PS or power steering pump can be activated with the engine stopped. This is the first one. Second one is when starting the vehicle. The movement of brake pedal is released. The movement of the brake pedal is released. Motor or generator starts the vehicle at the same time. This is the electrical vehicle the driving in. When the driver steps on the accelerator pedal, or after a given period of time has passed, the engine firing occurs, and the engine combustion and the engine driving mode will start. Next is when running in the ordinary condition. The vehicle runs powered by the engine, same as the ordinary vehicle. When deaccelerating. Upon the braking, the vehicle wheels deactivate. Upon the braking, the wheels activate the motor or the generator for power generation, and some of the brake deacceleration energy is recovered and stored in the battery. Now coming to the system configuration. The picture is showing the system configuration where this is the engine, where the engine is connected with the motor or generator and the auxiliary. An engine is in the engine, there is a starter is connected. Motor or generator is connected with this inverter in it, where the inverter or the battery cell is there. From there, 14 volt is connected with the 12 volt battery, and inverter or the 42 volt is connected with the 36 volt battery. And the starter motor is directly connected with the 12 volt battery. Since extensive applicability has a since the extensive applicability was prerequisite of the mild hybrid system, the emphasis was placed on the installation easy. Hence, motor generator expected to work as a prime mover of the system, which is designed to minimize the engine modification. Specifically, it is installed at the location. Where the alternator used to be installed. The alternator used to be installed in the conventional systems. The power is then transmitted through the belt to the starter remain in the configuration as it is necessary to start the engine in the initial state. The size of motor or the generator is minimized, suppressing the torque requirement. Aiming at a compact design, the inverter, DC to DC converter and the total system control units are combined into a single structure so that the resulting unit can be accommodated in the space provided for the conventional battery. An electromagnetic clutch is provided as a shut-off mechanism between the engine and the belt for the auxiliary equipment. Owing to this clutch, the driver can use two comfortable systems. One is air conditioner and second one is power steering with pieces easily even if the engine is stopped. Two power supply systems of 42 volt and the 14 volts are installed. One is for motor or generator and another for the conventional power supply. The motor or the generator so the inverter charge the 36 volt battery. While DC to DC converter charges the 12 volt battery. As the main power supply is the 42 volt system, it should be able to cope the power requirement of the next generation 42 volt vehicle. So students, in the today's class covered the second part of the power measuring, then study on 42 voltage system, hybrid system and its configuration. So next classes, on the next class, students will discuss the various components of this hybrid system. So still then, stay at home and stay safe. Thank you so much students.